session in half-hour sections. Our first presenter is Dr. Robin Rothfeder. Robin's going to, the title of his talk is Prioritizing Wisconsin Lakes for Conservation and Restoration. Robin is an assistant professor at UW-Stevens Point, and he's a specialist with the Center for Land Use Education. And Robin's going to really talk, hopefully, a lot about, and both talks are, the importance when we're doing lake management projects, how important it is to bring in the human dimension dynamics when we get to doing our planning, our prioritizing, and our implementation of lake management projects. So with that, I'm going to turn it over to Robin now, and then we'll introduce Dr. Joe Norner on the half hour and start his talk.
Great, thank you, Buzz. Appreciate the introduction. Thank you everyone for being here. Really exciting to have this great turnout in our digital platform here, and just want to say a special thank you to Peggy and Sarah for coordinating the session, and everyone just involved in moving this conference to a fully digital platform in such a short span of time and doing such a great job organizing and coordinating that. It's been really impressive to watch, and really excited to be here. So as Buzz mentioned, I'm a professor in the Natural Resource Planning program at UW-Stevens Point, and I'm a land use integrated specialist with UW Extension. The project that I am presenting on today is something that I've been working on with Eric Olson, who runs our Lake Center here, and I'm sure everybody is familiar with, and a grad student of mine named Susie Toivonen. The focus of our project has been on how to utilize data to help set priorities in lake conservation and restoration work. So this is really about recognizing that, as we see here, there's this huge universe of water bodies in the state of Wisconsin. There's limitations on funding, resources, human capacity to do conservation and restoration work. And so how do we set priorities? How do we decide where to focus our efforts? Those are the questions that I'm going to speak to a bit today. Stay here for just a minute for me, Sarah. So this here, we're looking at the kind of whole universe of lakes that we're including in the data sets that I'm building and working with. We've included anything that the DNR, Wisconsin DNR, has classified as a lake, a pond, a reservoir flowage. We've got some big oxbows in there even. We've got any water body with a name, excluding teeny tiny, less than 1 acre sorts of things. And anything that's over 20 acres of water, even if it's unnamed. And at least 4,000 water bodies that fall into that category, and probably quite a bit more. Next slide, Sarah. This is just quickly recognizing, and something that everybody knows really well, the social and economic importance of lakes in Wisconsin is just so significant. It is a core aspect of place identity, of lifestyle and livelihood, and such an important element of Wisconsin economy as well. This estimate, $1 billion, is real estate that's currently on the market. And we'll see that that's actually a massive underrepresentation of the total value of lakeshore real estate. And I'll be talking quite a bit about not just lakes, but properties adjacent to them today. And that's really recognizing that land use practices and decisions are some of the driving factors in lake quality. So about 1 in 5 surface water bodies in Wisconsin are impaired. And a majority of those cases are driven by something related to land use, mostly either sediment loading or nutrient loading. Next slide, please, Sarah. So, you know, the kind of larger question that Eric and Susie and I have been asking related to this multi-part project that we're working on is, how do we use data to measure or even rank the lakes, the resources that we've got in Wisconsin to help us do that strategic data-driven decision-making? And I think broadly speaking, you know, we can characterize kind of two areas where it makes sense to do measurements. So one is just biophysical characteristics. What's going on with water quality? What's going on with water clarity, wildlife, habitat, other characteristics like that that just indicate to us kind of the quality and nature of a water body. And then the other category for assessing lake characteristics is in terms of socioeconomics. So, you know, how do people use the resources? What sorts of value do we place on the resources? And what sort of role do those resources play in markets, in development, and those sorts of things? And it's really this socioeconomic component, like social science, that I'm going to be speaking about a bit today. Next slide, Sarah. And so in addition to lakes, something that I'm really focusing on here today is property that's immediately adjacent to lakes. And that's for the reason that I mentioned, is that land use decisions on those properties play such an important role in what ends up happening to the lakes. So for this project, we've defined a lakeshore or a shoreline parcel as any distinct piece of property that's within 100 feet of a water body. Found about on the order of 200,000 distinct parcels of property that fit that criteria. And those are representing something on the order of 80 million feet of shoreline property frontage. I found this a pretty eye-popping number. And I do want to just note and emphasize that we should treat this as a pretty rough estimate. There are a number of reasons for that, but basically the DNR, you know, they curate a lake database. There are kind of a number of potential sources of error and inaccuracy just in that database. Every county curates their own property database through the tax assessor, and then that's aggregated up to the state. And so again, there's various sources of error and inaccuracy there. And then when you bring those two data sets together, some of those things cancel out, others of them compound. So this is just to say, we should be generally confident that there's in the 8 figures of feet of frontage, and not be overly attached to this particular number. But 80 million feet does represent approximately 16,000 miles of frontage. I placed a question around this issue of valuation, like what are the properties that are adjacent to our lakes worth? And the reason for that is this universe of property that we're looking at in red here is both public and private property. And it's not that clear, right, how you estimate, say, like the market value of a big state or federally owned park or forested area. It's the valuation for public properties of that nature is a bit unclear. So next slide. We'll especially here focus on privately owned parcels of land for the reason that it's much more clear and straightforward how to estimate the value of those properties. So you can see here the majority of the shoreline properties, if there were about 200,000, the majority of them are privately owned, but only those private parcels only constitute about half of the total shoreline frontage. And that makes sense if we think about, well, it's the publicly owned parcels are these very large blocks of land that are managed by the state, county, state, or federal governments. And so it makes sense that even though the count is smaller, the frontage on our lakes is equivalent. So I found these overall summary values, again, pretty eye-popping. Just the land, what I'm calling dirt here, that's adjacent to of private property that's adjacent to lakes, is worth something on the order of $20 billion in total. And then the improvements that are on developed properties, buildings, infrastructure, those sorts of things, are valued at about another $20 billion. So the total, what we call the estimated fair market value of private shoreline properties in Wisconsin, is something like $40 billion, basically just the sum of the dirt and the improvements, which just gives this pretty incredible picture, I think, of what lakes and lakeshore properties are contributing to the Wisconsin economy. And the average per foot value of that property frontage is about $1,300 per foot. Next slide, Sarah. So we can start to kind of further parse this data apart in different ways. And I think a particularly interesting and important way of doing that is by breaking down which properties are developed already and which properties are currently undeveloped. So we can see the majority of those privately owned properties are developed, and that constitutes roughly 3/4 of the lakeshore frontage that fall into that category. We can see that the vast majority of the market value of these parcels is represented by the developed areas. So we see again approximately even split between the land and the improvements, and that even slightly higher average value per linear foot. These developed parcels and lakes that have development around them, as we know, are maybe a higher threat for degradation. And some of the data that we'll continue to look at here, might be able to help us make the case, where is restoration especially important? One way of thinking about that is, well, where is restoration efforts going to deliver the best return on investment? And these are, this is kind of the universe of property and lakes where we would start to maybe ask questions like that. Then next slide, please. The other quarter or so of shoreline frontage and shoreline parcels is undeveloped. We see the market value as we would expect, and the linear per foot value of those properties is substantially less. That makes sense. And in this case, though, we would probably say it's lakes that are less developed and properties that are not developed that are great targets for conservation work. So if we're saying, hey, we'd like to invest in conservation easement in shoreline adjacent property to protect it from future degradation, well, it would make sense to focus on this universe of property that's in a currently undeveloped state. Next slide, please. So we can continue from those statewide summaries, we can kind of continue to drill down to finer and finer levels of detail. I've generated rankings by county on all of these different criteria for every county in the state. What we're looking at here are some top 20 lists. We don't need to spend too much time trying to dig through most of these. I'll show a map that's easier to parse apart here in just a second. We can see that in terms of total frontage and total amount of property value, things are kind of concentrated in the north and northwest. We would expect that. I think this third table from the right is especially interesting here, and that's where I'll draw your attention. This is, I calculated what percentage of the total real estate value in a county. So all of the parcels, all of the properties in each county, what is the total estimated real estate value in the county, and then what percentage of that total value is constituted by these developed shoreline parcels. And so you can see in our top 20 list here, especially the top half, you know, there's at least 10 counties where 40 to 50% or more of the total property value in the county is constituted specifically by lakeshore properties. I find this pretty remarkable, and I would hope, you know, could help some folks that are in some of these counties make the case, make a data-driven case about how important restoration and conservation work might be in their area. And then we can see that in terms of the value per linear foot, the spatial distribution is somewhat different. Next slide, please. So this just gives us that sort of visual image. These are just the top 10 from the tables I was showing here. Once again, we see that in terms of the total amount of shoreline frontage is really concentrated in the north and northwestern part of the state. And that makes sense. That's where the most lakes are. That's in the blue hash that you see on your screen. In terms of the total market value, just summing the value of each of those parcels, there's kind of this bifurcated structure. So there's high total value in the north and northwest we see, and then also another set of properties like that down in the east and southeast. And then we see the highest per foot valuation is probably where we would expect. And that's really completely concentrated in the eastern and southeastern parts of the state. Now, these are different ways of measuring, assessing, ranking, or prioritizing different types of places and different types of lakes. And I think there's different stories, important, relevant stories that folks could use this data to tell, regardless of where they're at. Next slide, please. And we can look at the same sort of data and information thinking about undeveloped shoreline. Once again, we see the total amount of frontage and value concentrated in the north. It's pretty remarkable. The values for Oneida and Vilas County specifically are, in this case, an order of magnitude higher than anything else. And I think that is just consistent with the distribution of lakes overall in the state. Let's see, I'll have you go to the next slide, Sarah. So I'm seeing one question here that I'll address right away, which is, does the data include the Great Lakes? We excluded the Great Lakes from these analyses. And that does obviously change the distribution of how some of these tables shake out quite a bit. But we just viewed the Great Lakes as so qualitatively different from anything else that it just made sense to exclude them. So once again, here we see undeveloped frontage, mostly concentrated in the north. Somewhat interesting, I thought, when we look at what percentage of the shoreline in each county is not developed, kind of a different part of the state pops out, this kind of strip up the middle of the central part of the state. And that seems to me to be representing places where there actually just are fewer total water bodies and less really high value types of lake and shoreline. And so maybe makes sense that there's less development activity taking place in some of those places. And then once again, where the overall real estate market is the most expensive, we see the per foot value even of undeveloped properties concentrated there. Next slide. So drilling further down, and what I'm working on with my grad student now is summarizing this information not just by county, but by township, and even by lake, by each of those many thousand lakes that are represented in the data set. And so pretty remarkable here to see things like some of these big lakes that we would expect, Lake Geneva and Lake Winnebago, are each showing over $1 billion of total real estate value just on their shoreline alone. Really really remarkable statistics, and some of the market value per square foot numbers are pretty eye-popping as well. I will say on this particular component, the furthest right table, that's something that is going to require some additional cleaning on my end before it's really ready for full-scale consumption and delivery. So for example, if we've got a tiny lake and it's got one mansion, you know, that's on the shoreline, that's going to really artificially inflate this per foot value estimate. And so we take some of these things with a bit of a grain of salt. Next slide, please. And this is, again, just the top 10, looking at the distribution of just some of those big, really popular, you know, high-end tourist destination sorts of lakes. We'd probably expect those to pop out in a top 10 list of this nature, and that's borne out when we look at kind of the spatial component of the data. Next slide. Okay, so where is this project going? I saw a question pop up that was asking how can folks get access to this sort of data. So the next step for this project is going to be making the total source data for some of these top 20 tables and maps that I've been showing you publicly available through sortable lookup tables and maps. And we'll look to provide that to you at the county, township, and ultimately at the lake level. So that folks in the audience, stakeholders, decision makers, you know, all the people out there can start to look up and say, well, what's the shoreline properties worth? What are the lakes worth in my county, or this particular lake that I live on or that I care about? We'll make this data available to you that you can sift and sort through to utilize this information for your own purposes. And then also what I'm showing here, I'll look to provide a higher level of detail, which is things like, okay, in each county, where are the biggest blocks of contiguous undeveloped shoreline, for example, that would make, all things being equal, maybe the best target for conservation easements or those sorts of things. That's one next step, making a lot of this data at various spatial scales available in a publicly accessible way. Next slide, please. We, with the Lake Center, have conducted a survey of lakeshore property owners, statewide survey that you can see in the left image here is just a summary of the 1,100 responses that we got. To us, looks very well representative, coverage across the state. And something that I'm really excited, just starting to dig into the data that's in these surveys to learn much more about how are people thinking about evaluating, managing, you know, strategically addressing the lakes that they live on. So that I think is very exciting. On the right, kind of an interesting component of a project I have my grad student working on, which is looking at where lakeshore property owners who have their main postal address out of the state are coming from. And so this is just a big, rough overall summary. But even here, we can see these kind of hot spots, people coming from the Bay Area, from Los Angeles, from urban Texas and Phoenix and Seattle and Miami, things like that. Folks coming from Canada and Europe. Kind of interesting to see what a draw, national and international draw, Wisconsin lakes are. Next slide. And then ultimately, the highest level, most complex, but probably ultimately most useful tools that we will eventually look to build will be integrating some of the social and economic data that I've been talking about today with physical lake and environmental quality data. And this is what will enable us to ask, you know, more sophisticated questions like, how do property values change over time if lakes become less clear or more clear, for example? So that's sort of kind of higher level combination of social and environmental information that can really, I think, help to guide, again, prioritization and strategic decision making about how we can make limited resources go as far as possible. Next slide, please. So pretty simple in terms of conclusions. There's a lot of ways, right, to parse apart the data that we have on our lakes, and a lot of really interesting and relevant and important patterns. And some of those, you know, are spatially divergent, and which is interesting. I hope it's clear just the way that we can continue to add value to conservation, restoration, and decision-making through data-driven tools. And of course, this really is just kind of the tip of the iceberg, and there's lots more to do. Next slide, Sarah, please. I'm gonna leave my presentation here, and I think we've got a few questions that have come through. I tried to address some of them. I saw one question from Ralph: did you separate residential and commercial properties? In what I presented today has residential and commercial properties aggregated together, but I eventually, in some of the sortable lookup tables that we make available, you will be able to sort out residential from commercial. A note from Pamela, surprised. I wonder if a bunch of people are thinking this. There's a particular lake or a particular county that they're expecting to see on one of these top 10 or 20 lists that they don't see. And particularly, like I said, some of the foibles with the lake specific data and how the per foot value, how I've currently summarized some of those things is going to need to be cleaned up, and I think just further parsed, maybe by large, medium, and small lake, by location within Wisconsin. And then some of those, what you might be thinking, oh, there's a blank spot in that list, we'd expect probably to see things show up the way we expect them after I've done some of that additional data processing. Maybe open up to additional questions with the last couple of minutes before handing off.
Ralph asked, lake quality and water quality are perceived differently by riparians and lake users. How will you address this with your continued work?
Yeah, I think that's a really great question. I'm going to be interested to see these issues of perception of resource quality is covered in that survey that I mentioned a couple of slides back. And so one thing that's going to be really interesting to do is to see if people's perception of their lake quality matches what the biophysical data tells us about trends in water quality in those places over time. And so I think it's through this survey work that we're going to be able to get at things like attitudes, values, perceptions, those things that really matter. And we may even try to do a bit of like one-on-one follow-up with that survey for folks that have provided contact information and say that, you know, that they've been willing to receive a phone call or whatever. And I think that'll also help us really dig into some of those finer grained social components like Ralph is asking about.
Okay, we have one final question for you, Robin, and it says, basically, what attribute would you like to include in your data set if money wasn't a problem?
Oh, that's a great question. I mean, honestly, I think we were really lucky to, we just kind of had the right timing and circumstances to be able to do a pretty detailed survey. We got 1,100 responses, which is a large sample size. And, you know, Eric just happened to have some funding ready to leverage for that. But I think it would have to do with some kind of rigorous, high level, you know, complicated data analysis and modeling, some stuff that's probably over my head, which is why I've got some great grad students and collaborators. But I might have to punt on that question. It's one that I would defer to Eric probably and some of the other partners and collaborators in this project, but it is a great question for sure.
Well, thank you, Robin. And let's give him a round of applause as we switch gears for Joe Norner. And Dr. Joe Norner is coming to us from Michigan. Joe is the coordinator for the Midwest Glacial Lakes Partnership and the Inland Lakes expert for Michigan Department of Natural Resources. Joe received his undergrad at Notre Dame, his MS at Michigan, and his PhD at Michigan State. He seems confused about what football team to root for. No problem, Joe. Go Bucky. So, so can we turn it over to Joe now for his presentation, please?
Buzz, are you able to see the slides?
Yes, we are, Joe. We're
Excellent.
good to go, I think.
Thank you. Well, thank you, and thank you all for attending this presentation and this series of presentations remotely. I know it's quite a unique experience, and so I'm really honored to be part of it, and I want to first give kudos to the organizers for this conference for putting it together and for being so flexible and adaptable. So today I will be talking about the conservation planner that was developed by the Midwest Glacial Lakes Partnership. And I'm really just the tip of the spear on this, or maybe I'm the caboose. I don't want to give myself too much credit. So the partnership consists of quite a few different folks, and the folks that you see listed on this slide are the science and data team, and they're really the ones that have helped to develop the assessment and the conservation planner tool. And so I want to first give a lot of credit to the folks that you see listed below. So what I'm going to do is just talk briefly about what the Midwest Glacial Lakes Partnership is, first of all, and then talk about how we developed this assessment and this tool for understanding lakes at a regional scale, what some of the data needs were. And then I'll take the second half of the presentation and just do essentially a demonstration of the tool. I'm going to do that live on my internet, and we're going to cross our fingers that we don't have an internet crash or otherwise glitch along the way. So, or a one-year-old wake up in the room next to me. Okay, so the Midwest Glacial Lakes Partnership is a conglomerate of 8 different states across the upper Midwest. And it's called the Glacial Lakes Partnership because the lakes in that region are defined by their glacial origin. And so they all have a certain character to them. And we wanted to be able to, the partnership's reason for being is to be able to conserve and protect those lakes. I want to give you a sense first through this map of where the partnership is. And you'll notice, for example, that the driftless area is not in the partnership. And of course, the reason for that is in the name. It's the driftless area. So we have about 700 partners in the partnership right now. The partnership entails about 40,000 glacial lakes and about 89,000 miles of shoreline across the partnership, and close to 6 million acres of surface area for lakes. So if you were to walk the shoreline of every lake in the partnership, you would be able to go around the Earth 3 times almost. So pretty large area, and a lot of things to think about and prioritize and weigh as the partnership evaluates where to conduct its activities, where to do its conservation grants, et cetera, et cetera. I've listed the icons, the badges of all the various organizations that are part of the partnership steering committee here at the bottom. And so the Michigan Department of Natural Resources is who employs me. I actually work in Michigan. I'm in East Lansing today at my home. And I work for the partnership representing all of these steering committee partners and all of our other partners. I, of course, had to take the opportunity to shamelessly self-promote my fishing prowess. I got lucky one day and caught that fish But just a little bit more about the partnership. I'm the coordinator. And so my job is to work with a bunch of people who are extraordinarily talented around the partnership, and to help them to coordinate their activities so that we can be working together to put together products like the one I'll show later. Um, and as you see, the partnership's mission is to work together to protect, rehabilitate, and enhance sustainable fish habitats in glacial lakes um, for the use and enjoyment of current and future generations. Um, and that future generations part is a critical thing for us, because it really entails us looking toward the future in terms of what kind of conservation we're going to be prioritizing and emphasizing through the partnership. So what does the partnership do? We do a few things. First, we conduct scientific assessments, and scientific assessments are really one of the flagship products that we've been doing over the course of our first 10 years. We were created about 10 years ago. And so I'll show some of those results today through the conservation planner. The second is that we enable partners to complete on-the-ground habitat conservation projects. So we operate a grant, and that grant gives out between $200,000 and $300,000 every year for lake conservation projects. At the end of the presentation, I'll share a website, and I would encourage you to check that website out if you think you have a project on a lake that's a natural lake in the partnership, and want to look into whether you could do a habitat conservation project through the partnership. Check us out, shoot me an email, and we can talk more about the potential there. The next thing we do is we conduct education and outreach. Our education and outreach team consists of folks across the partnership as well. It was formed about a year and a half ago now, and has some really neat products that we're looking to launch this spring and summer, helping to promote things like natural shorelines. And then finally, we provide a forum for those seeking inland lake fish habitat conservation to share strategies and resources. And so we have a webinar series that provides information on cutting edge science and management. We tweet, we have a newsletter where we share information that we're learning from the various partners. And so it just provides an opportunity for folks that are involved in the partnership to share their ideas and to learn from others. And I want to say too that when I say fish habitat partnership, we define fish habitat very broadly. And so we're not thinking of fish habitat as just the structural habitats that an angler might target when they're going fishing, like large woody debris or aquatic vegetation. We're thinking also very broadly about all of the needs that a fish has throughout its life. So it needs high water quality. It may need the ability to swim up into rivers to spawn. So we define habitat very broadly in terms of the biological, physical, and chemical components of habitat, and thus, I think from a functional perspective, we're really a lakes conservation partnership, and our motivation, what brought us together, and frankly where our funding is motivated, is fish, but that doesn't limit us or our interpretations of how we move forward. And so I mentioned that we do assessments, and I'll spend a little bit of time talking here about the flagship assessment that was produced. So the partnership has 40,000 lakes, and it's got all sorts of different types of waters located across the partnership, from small shallow lakes in Iowa and western Minnesota and the Dakotas, to the deeper lakes that you would see in Wisconsin, shield lakes in the northern areas, and everything in between. So a very diverse set of lakes. And we wanted to understand something about the condition and resiliency of those lakes, the resiliency to change. And then we wanted to be able to help partners prioritize actions and funding and provide some information for us as we operate our own grant. But as we heard in the previous presentation, prioritization is something that takes a lot of social science work as well. And so what you'll see when I go through the conservation planner is that we don't actually identify priorities, 1, 2, 3, 4, 5. This is the list we want to go down. Instead, we try to identify through this assessment the types of actions that you would want to take on every lake, because of course, almost every lake has property owners on it, and every lake has stakeholders who want to see the best for that lake. And so we're trying to understand prioritizing actions as on each lake as opposed to prioritizing lakes for action. And so I'll just take a second to briefly outline what our framework is for this assessment. Remember, we've got 40,000 lakes. And so we went out and collected species data from state agencies and other partners on all of these lakes. We didn't collect any data ourselves. That would be entirely unmanageable. And this was a really big effort just to collect the data from the various states and to pull it together in a similar database. And then we collected GIS data on land use and land cover, expected nutrient deposition. We collected data on current and future air temperatures, and by virtue of those, what we think the surface temperatures for lakes would be. We collected data on the position of the lakes within the landscape, and a number of other factors: lake size, lake depth where we have it, shoreline length, and we gathered all of those variables into a GIS database, which is just a map-based database, and we ran some models in a random. The modeling program is Random Forest, and it's a program that uses classification trees, a large number of classification trees, to identify the clearest and simplest patterns, predicting the variable of interest based on the predictor variables that you have available to the model. I'm not going to go into a lot of details on the modeling because I want to be able to focus on the planner that's resulting from that. But then what comes out of that is a list of species distributions for 4 species that we look at, and I'll go into those in a second, and then some metrics of vulnerability through metrics of human disturbance and land cover change, and then climate change. And we can allow those to help us to inform our conservation planning in terms of what recommendations we would give for each lake. And so the species that we looked at, we wanted to pick indicator species or guilds across a large number of states that were representative. And so species that we see across almost all lakes, or almost all states in the partnership, include bluegill, northern pike, and walleye. And then we have a thermal guild representing cold water fishes, which I'll represent with Cisco, but also include things like burbot, lake trout, and others. So we produced these species models, and what you can see is that the cold water fishes, hopefully you can see my clicker here, the cold water fishes in the upper left, represented by this Cisco, are typically predicted to be represented more in the northern part of the partnership. Cool water fishes have a larger distribution, and then bluegill have the most broad distribution among the partnership. Now, those of you that are familiar with your fish distributions may already be saying, wait a second, I know of a dot on there where I know that there's fish present. And me being a guy from Michigan, I know that we have some Cisco in this area and in this area. And so what I'll tell you right off the bat is that these models are really good, but they're not perfect. And they allow us to say something about every lake, but they don't tell us everything about every lake. And so they're best used to help us understand general patterns across the landscape. They're not as appropriate to be used to tell you which fish are in which lake. If you already have existing surveys, if you have other data for those lakes, then these models may not be the first choice of where you would want to go for your data. But they help us say something about every one of the 40,000 lakes. And in all of the states, the various agencies that manage these resources aren't able to sample every lake. And so it gives us a starting point for what the lake would be suitable for from the fish perspective. So we've assessed agriculture and urban development in the 100-meter buffer around the lake. And so that gives us an indication of shoreline development using National Land Cover Database data. And we did the same thing in watersheds. And when I say a watershed, what I mean, some people will call it a lake shed or a catchment for the lake. We developed specific lake sheds for every lake and then tallied up the land cover classifications within that. So here's an example for Green Lake in Michigan. We assessed climate resilience through our species models. Our species models relied on temperature, and we used forecasted climate change models downscaled to assess whether species are likely to be present or absent in lakes in the future. And if a lake had cool or cold water fishes now, but loses them in the future, then we determined that it was not resilient to climate change. So now I'm going to do a demonstration of the planner, and what you would want to do then is if you're on your web browser, go to midwestglaciallakes.org, and it'll bring you to this website. The website, if you scroll down, has a number of resources, and there's a drop down here where the conservation planner is featured. You can click on it. I'll note that the planner works with Chrome, Firefox, Safari, and everything except for Internet Explorer. So don't use Internet Explorer when you're trying to use it. Click on the planner and it'll launch the planner. And first thing that happens is there's a pop-up that tells you that information. And okay, so here's the planner that I've been talking about. So I'm going to zoom into Wisconsin. I did my master's research in Wisconsin, and so I'm going to pick a lake, let's see, North Twin Lake. So if I want to know something about North Twin Lake, I click on the lake, the dot for the lake here, pulls up the lake, its size, which county and state it's in, which watershed in the HUC 8 framework, and then a database ID that we have. We also note that Cisco have been documented in the lake, and the partnership has developed some updated models for Cisco. And so we flag that and say, if you want more information about those models, they're not incorporated into the model yet, into the planner yet, but please reach out to us and we'd be happy to talk through those with you and share the information. So when I clicked on North Twin, you might have noticed that this panel of meters and dials below popped up and started to display information. First, climate vulnerability. North Twin is projected to lose a cool or cold water species. Specifically, it looks like cold water species are likely to be present in 2018, which is consistent with the fact that Cisco have been documented. But according to these models, they're unlikely to be there in 2050. The watershed is 6% disturbed. That means there's 6% of the land cover was identified through the National Land Cover Database as agriculture or urban development, and 18% of the shoreline, or the shoreland, the land around the shore, was developed or agricultural. And based on those, we provide some general recommendations. So generally, protection is more efficient and more effective than conservation or than restoration or rehabilitation. And so when disturbance is low, in this case, then we recommend focusing your efforts on protection. But there's always going to be a place for some rehabilitation and mitigation as well. Similarly, along the shoreline, you notice this in the yellow category. We have 3 categories: high, medium, and low. And so this is in the moderate category. And we recommend, again, because protection is cheaper and more effective, still focusing on protection, but rehabilitation and mitigation is a larger fraction of what an interested stakeholder might focus their efforts on for North Twin Lake. If you want to dig into those data a little bit more deeply, you can click on the watershed details, and I'll draw your attention to this table on the right, where you can see the watershed summary for this lake. So across the top, you have the land cover classifications, and then along the left-hand side, you've got protection status from the Protected Areas Database of the United States. So fully protected would be something like a state park where logging and those sorts of activities aren't allowed. Partially protected might be a state park where there's mixed uses, or maybe there's some selective logging on a forest service property. And then no protection would be private properties with no easements on them that could be developed and modified really in many ways. So you've got this grid then of the various land cover types. And we can see then that the North Twin Lake watershed is 46% in forest, about 5,000 acres of the watershed. About 18% of it is wetland, and 5% of it is urban, 2.2% of it is agriculture. And similarly, about 32% of it is protected, and about 67% of it is not protected. So if you're a land use planning organization, or if you're a land trust, for example, those might be things that are valuable to you. And you could do the same exercise along the shoreline to look at where the development and the protected areas are along the shoreline. This donut plot on the left shows the same information in a slightly different way. So here you've got urban at 16%, and urban and no protection is also 16%, but there are it breaks it down by subcategory as well. So that's the information that we have for each individual lake, but we also have information, we have a way to show that information for all lakes. And so let's say that you're interested in doing a more regional level analysis. I'll just look at the Northern Highlands area here. And you can change the color of the lakes to represent data that I've presented. So the disturbance, you can pick watershed disturbance, shoreline disturbance, or climate vulnerability. We'll look at watershed disturbance here. And what you see is that according to this key, low watershed disturbance, most of the lakes in the Northern Highlands district are low watershed disturbance, which makes sense based on what we know about this area. But if you look in southern Wisconsin, for example, southeastern Wisconsin, you see more watershed disturbance. Similarly, you could look at shoreline, and what you'll see is a more heterogeneous pattern. So if I zoom in here, you'll see a mix of red and blue dots scattered throughout the Northern Highlands. And that reflects the fact that some of these lakes have more development, and so they may have really pristine watersheds, but they're high value, as alluded to in the previous presentation, where people are really focusing on building cabins, and they may have pretty high levels of development. But you can look at suitability for a species. For example, you could look at, we'll pick northern pike and current. Okay, so this shows where we think northern pike are currently distributed. The red draws your eye a little bit more, but there's a lot of blue in there too. And then look at 2050, and if you kind of toggle back and forth, you can see that there's a little bit more red when you get to 2050, because we expect this part of the world to warm, and pike prefer slightly colder waters. So I'm going to go back and I'll just leave them classified by watershed disturbance. You can also classify them by the management guidelines that I recommended below. So you could classify them by the watershed management guidelines. Again, protection, you have more of these yellow rehabilitation and mitigation recommendations down in southeastern Wisconsin. But I'm going to leave it on watershed for now. And then you could also modify how you display this information by the types of lakes. So maybe I'm only interested in lakes that are relatively big, say 500 acres or larger. And maybe I only want to see lakes with low watershed disturbance, or in this case, maybe low shoreline disturbance. So I've turned off the medium and high shoreline disturbance and only shown the low. And maybe I only want to see those that have a medium climate vulnerability. We don't have a low category because all lakes are going to be affected somehow. And given the audience, maybe we're only interested in lakes in Wisconsin, so we filter out all the Minnesota lakes. And maybe we're only interested in lakes that qualify for a particular treaty if we're interested in more tribal jurisdictions. So it looks like the Treaty of 1837 is what these waters fall into. So now we've pared down our list into a pretty specific subset of lakes where if we had a conservation action that we wanted to target toward lakes that fit that category, here now we've got in all of Wisconsin, 6 lakes that meet those criteria. And so it could help conservation planning across the lakes. If you wanted to see some of the information that came into this, you could click on this background map and you could show, for example, the protected areas database. So this is when I was showing earlier this fully protected, partially protected. This is the protected areas database that I was referencing. You can show the lines for the ceded territories. You can show the ecoregions at the EPA level. There they are. You can show land cover. I'm not going to try to load that because it's a really large data set, and I'm also broadcasting video right now. So there's a number of ways to display it, and I think really what this gives us is the ability to try to communicate things. One of the next steps. Oh, and one last thing that I want to highlight is that if you want, you can then copy the link and say, let's say I was just zoomed in right here and whatever this lake is, I was really focused on it. I could copy that link and paste it into an email or into a website, and I could share it. And so if you're interested in your particular lake association, you could do that. The next thing we're going to develop is a mechanism so that people could develop a lake report that specifically looks at all of the variables that we've got and provides some implementation and recommendations based on those variables. So with that, it looks like I've got just 2 or 3 more minutes for questions. I see a few questions have popped up here. And so I will finish. And I've got my information on, I'm going to drop it into the chat box here. So if you want to play along with the partnerships conservation planner, you can click on the first link, check out our website. You can sign up for our newsletter using the second link, and then you can follow up with me with any questions at the email address below.
You ready to start the questions, Joe?
Yes.
First one there, I'm sure you're looking at the chat box too. How is the Midwest Glacial Lakes Partnership funded?
The partnership derives funding from the Fish and Wildlife Service. We are supported through some of those grant funds that I referenced earlier, and then through contributions from each of the state agencies. So the Wisconsin DNR, for example, contributes $10,000 to the partnership.
You want to take that second one from Dane Whitaker there then?
Sure, yeah, thanks. So the MGLP engages with non-angler stakeholder groups through its education and outreach team, and through the webinars and newsletters and the tools that it creates, but it doesn't directly work with stakeholders. Typically what we're doing is more developing tools for our partners who are conservation professionals, educators, researchers, managers, to help them do that sort of work. And so directly we're not working through those, for example, farmers as much, but we're certainly working with them through the grants that we're funding, for example, where we're one of our grants that was looks like we might fund soon is looking at funding. Well, I shouldn't go that far. It's a focus for us with our grants. I'm going to leave it at that. The next question from Pamela Tosher: can users download a spreadsheet that lists the lakes represented in the map searches? And the answer is no, not right now. We're hiring a database coordinator that's going to work with us over the next 2 years, and that's one of the things that's on our list, so that people can pull out the queries that they've generated. I see a number of other questions. Buzz, do you want me to continue answering them?
Yeah, I think folks got a minute or two. Let's take another couple minutes yet. These are pretty good questions, and I think you just demonstrated a very powerful tool for a lot of people. So let's continue on, Joe.
Sure. So Greg Berg asked, can you explain where the data is coming from or for the planner and its accuracy? And for example, how shoreline disturbance is determined on this large of scale with so much area and so many lakes. So it's all from, except for the fish data, it's almost all from national level data sets. And so the National Land Cover Database in this particular example is derived from the satellite data. And so that's on 30-meter pixels that have been classified on a little bit finer resolution of categories than what I showed. We lumped them together into 5 or 6 categories, and then we summarized it within the shoreline or the watershed areas of each lake. And I'll note that when the satellite gives you a slightly different number that is highly correlated to, but not exactly the same as what you might get through a different method. And so every method is going to need to be cross-referenced a little bit. So if you went out and mapped all of the shorelines and looked at the linear footage of shorelines that are developed, you might get a slightly different answer than if you looked at what the satellite tells you about that shoreline. And so that's a little bit about where the data came from there. But I'm happy to follow up much more in detail.
We'll take one more question and then we'll have to cut it off.
Sure, okay. So the question is on land cover data coming from 2006. And the answer is that we developed these summaries based on what was available from the National Land Cover Database. And so these summaries were put together when the partnership was originated in 2009, and then they brought together the summary. So there are slightly more updated land cover, and with the new database coordinator, we're going to work on pushing those into the viewer.
Well, I'd just like to thank Joe and Robin and Peggy and Sarah for helping make this session happen this morning. And you can go back to the agenda and join us after lunch. We got a bit of a break here now. And so with that, I think folks we'll end the session at this time then.